what does technical debt actually mean? Now, we software engineers, especially working on service-based projects and the like, we often use the term technical debt to describe inefficiencies in the code base, poor software quality foundation, and other things actually preventing us from building on top of an existing code base. And now this is a pretty fine balance between being able to provide a usable piece of software quickly for the rest of the public and actually building something that scales over time. Now, there are different ways to get this problem solved, one way or another. Some do incur building a very cheap, poorly built, minimum viable product simply in order to launch something for the market and then paying for a very expensive migration to something that's properly built. Some do include paying, again, a very tiny sum of money for an initial build and then incrementally increasing maintenance and support costs over time simply because the initial code quality is extremely mediocre. So you're basically kind of paying debt with a very high interest rate over time. And of course, some do invest a lot more in the initial build only to be able to provide something that is easily scalable and kind of grows over time. Now, the reason I'm bringing this subject in is I spent the last month and a half with dozens of sales negotiations and different types of partnership meetings, plant meetings, growth meetings, planning for 2019, and of course, estimates and different types of pricing discussions were one of the most important things throughout the conversations, right? Because pricing, of course, matters. And now, with every single type of instance, one of the things I brought up the most was, do you want it to happen fast? Do you want it to happen cheap at first? Or do you want to save money over the period of several years? And some of the sales leaders I've been following over the years, they do often kind of transition this conversation between the cost and the rate. Well, it's actually the cost and the price of a specific product, being that the price is actually the lump sum that you're paying at once, and the cost is the ongoing fees and support and maintenance and everything else that's kind of happening throughout the period of this project. So this is a very good analogy here, essentially because having a product that is really poorly built isn't really something stable, isn't really something that grows over time, but it's in fact something that keeps you limited and basically you're paying more and more and more to just sustain the lifestyle of this specific product instead of investing in business growth, which of course is a pretty critical problem. So last week when I was reviewing my previous posts and notes, I found a link coming from another blog by Andy Adams, who used to be a Ruby developer, currently is running a WordPress performance consultancy. So he wrote a pretty interesting post about the 90%. You know, Perez Principle, 80% of the work could be done in 20% of the time. The other 20% of the work will basically take the rest of the 80% of the time, which is a very interesting analogy. But however, having said that, it's really easy to deliver the first 90% of a product, and it's extremely hard to patch all of those annoying bug fixes and compatibility issues and regressions and performance problems and whatnot, because everything else is built. Your foundation is obviously not quite stable because you still miss those 10%, and you need to patch and hack around a lot of things just to get the rest of the 10% done, which again is a major critical problem, and this happens quite a lot, especially in the WordPress space where we do work in. And what Andy essentially said, which really made an impression, is WordPress makes things so easy that everyone can jump in and edit the theme's header file, install a plugin here and there, update a few options from the backend, because this is essentially what WordPress enables you to do in general as an administrator. On the other hand, since he used to work as a Ruby developer, and I can also relate since my former background is a Java developer, I've done Python development as well. So, when you have an established programming language, you don't have a CMS, you actually have to build something from scratch. You're building the platform, and customers know that they can't really mess around with the code base because they don't have access to it. It's extremely foreign. You don't have all of those panels for just edit stuff and move and shuffle stuff around. Which again, this really makes the difference between the app and platform development, which most people understand is an ongoing technical cost for building a custom platform, and actually providing the very same thing, but on top of the WordPress platform, which is a foundation framework used on about 33% of the websites out there. So almost a third of all websites in the world are currently running on top of WordPress. So getting back to the technical debt topic, an answer that I stumbled upon by Tikhon Jelvis, who is currently working as a lead data scientist in Target. So he basically tried to sum up what technical debt actually means and what it also means for the organization. And he has kind of identified it with several different criteria, which are really interesting. So I'm going to kind of build upon all of them. So what makes is kind of what does, when discussing technical debt, what does quality actually mean? Why do we discuss quality of code in the first place? This is subjective, and kind of how are you able to assess it? So basically the ways you can access it is, the first one is navigation, the ability to sift through the code base, easily figure out what is built where by naming conventions, by folder structures, by other things that are extremely important to just find yourself around. Or when you have lots of dependencies, you should be able to quickly figure out what's connected to what, and again be able to basically map the entire route in order to get the job done. Second thing is understanding. When someone with a minimum experience in terms of code base, when someone with that kind of background jumps in and starts reviewing the code base, they should be able to understand what most of the essential code base is doing by simply reading it. So this means code comments, this means proper naming of variables, this means a decent breakdown of functions and classes and everything else, so that people can really find their way around and be able to start helping out quickly, instead of just wondering what's the purpose of this piece of code, how is this related to the other piece, and why are they so many pieces basically chained together in some, weird and unexplainable way. Third one is maintenance, which I deem is probably one of the most important ones. So maintenance is being able to take a piece of code that's built in, piece of project, and moderately quickly start introducing changes and applying some updates and applying some fixes without the entire platform collapsing in front of you, right? And this is really the main differentiator between a properly built platform and a platform that incurs a ton of technical debt. One of the most common examples is if you build a platform from scratch, or even if you're using, say, WordPress, and you build some plugins from scratch, just building your entire foundational layer. Connecting different pieces together is easy because your entire foundation has been predetermined to support this. It's been intentional, it's been thought for, it's been something that you expect to be happening over time. If on the other hand you bundle 5 plugins together, or like 5, 6, 7, 8, 10 large plugins together, which aren't necessarily meant to play well with one another, then it gets really tricky to start supporting certain things, because you have lots of dependencies and because you have lots of different behaviors coming from different pieces of software that aren't meant to support your initial goal. Like, they may allow you to enable certain pieces and kind of pull some triggers here and there, but actually making it happen is really a lot more complicated. Number 4 is performance. Obviously, technical debt incurs challenges if you have performance hogs, if you have speed impacts and other types of challenges on a software level. And the last one is correctness, actually making sure that the code is correct. It doesn't make false assumptions, it doesn't fall for different weird types of inputs from forms and from users. It doesn't store inconsistent data in the database due to lack of validation and so on. So this is kind of how technical debt impacts a project. This is a difference between a cheap one and fairly expensive one, I would say. This is a difference between taking lots of shortcuts at first and then expecting that things work in the meantime, in the prolonged period of time.